All right. So this part of chapter 9, we're going to start solving equations. We've done a little bit of this before, so I'll probably wind up repeating myself in these videos, but there's a bunch of different ways to solve quadratic equations based on what you have in front of you. So this first video is about isolating x, getting x by itself, in situations where x already is only in one spot in the equation. So that's a huge caveat, that when we have x existing in one spot, we just kind of undress x. Or here we also have x existing in one spot, even though it's an x squared. We don't have both x and x squared in the equation already. So we don't have x and x squared in the equation already. So we can work with this. So I want to show you, I also want to make a connection to graphing too. So if we're going to solve this equation, basically it's no different than what you would have done back in chapter 2. This is not particularly new. We're going to use division property of equality and divide both sides by 2. I'm not going to write down what I'm doing with as far as that goes, but that's dpe2. Then we're going to take the square root of both sides. Now, in actuality, when we take the square root of both sides, I don't expect you to write it this way every time. You're taking the square root of this and you're taking the square root of 25. So the square root of something squared is actually the absolute value of x plus 3. The square root of 25 is not plus or minus 5. It is 5. All right. The plus or minus that we would normally put over here comes from this absolute value, the fact that x plus 3 is equal to 5 or negative 5. All right. So most people will go from this step, x plus 3 squared equals 25, to this step. The square root of x plus 3 squared is x plus 3, and the square root of 25 is 5 or negative 5. All right. That's totally fine to write it that way. I just want you to see where this is really coming from, because the square root of 25, we've discussed many times, is actually 5, not or negative 5. The or negative 5 comes from the absolute value happening over here. Right? And then we need to subtract 3 from both of these values. So we get x equals 2 or negative 8. All right. Next one. We'll come back to this in a second. So next one says 2x squared minus 5 equals 9. So we're going to add 5 to both sides. So 2x squared equals 14. We're going to divide both sides by 2. So x squared equals 7. We're going to take the square root of both sides. So absolute value of x equals the square root of 7. So x equals 7 or negative 7. Okay, now there's a significance to these in graphing as well. So we're going to be using equations to solve word problems, but I also want you to think about the graph here. If you imagine subtracting 50 to move it to the other side, you could imagine an equation y equals 2 times x plus 3 squared minus 50. If you did the same thing here, you could imagine an equation y equals x plus 3 squared minus 25. All right. Now, these two graphs, these two functions do not form exactly the same graph. They have vertexes of values negative 3 for x, but their y values are different because this one is steeper. All right, this one has this 2 going on here. It makes it a steeper, narrower, taller parabola, however you want to think of that. All right, but both of these parabolas have x-intercepts equal to our solving of the equation. So they have x-intercepts of 2, 0 and negative 8, 0. So we go to graph it. Now, if we think about graphing that, if we were to solve this, we could have the roots for this. We could have the x-intercepts for this. We know where the vertex is in this. We kind of know how steep it is, but we can have the vertex and the x-intercepts and graph that function very easily by solving this companion equation, right? Same thing goes down here. We could imagine an equation like, like if we move this one around, y equals 2x squared minus 14, right? We know that this is a y-intercept rather. We know that this is a y-intercept. We know that it has a steepness of 2. We know that this is a parabola that hasn't moved over at all. So it has a y-intercept of 0. But then here, oh, I made a mistake here. These need to be radical 7 and negative radical 7. So these give us our x-intercepts. So just like in the one above, these give us x-intercepts. So we could graph this negative 14 and root 7. Root 7 is some number between 2 and 3, right? Root 7 at root 7. And we can graph this. Right? So these intercepts really help, and solving the equation that goes along with the graph can help you do graphing. All right. Next up, we're going to talk about, instead of when you can isolate x, when you're going to factor instead. So when you cannot isolate x, you got to do something different. All right. That's the next video we're going to do.